Hey girls, today we are going to be learning about multiplying a polynomial by a monomial. Just to review, a polynomial is a monomial or a sum of monomials, and it's only going to be one variable. And a monomial means one term. They can only have whole number exponents. We talked about this in chapter 7. Some examples are 5x squared y, or negative 2abc, or 1/2 rt cubed. These all have whole number exponents. Even if there's not an exponent written, like on this y, we know that that means it's an exponent of 1. And there's nothing added or subtracted on any of these. So we are going to be multiplying these together. Multiplying polynomials means that you have to use the distributive property. Remember, that is the property that says if you're multiplying a times the quantity b plus c, you take that a and you distribute it to both the first term and the second term. So you get ab plus ac. Let's take an example together. If you're trying to multiply this monomial, negative 3x squared, by this polynomial, 7x squared minus x plus 4, you're going to have to distribute the monomial to every term in the polynomial. It might help you to review. This polynomial has 3 terms. Remember, terms are split up by plus signs and minus signs. That's how I know that there's 3 terms here. And to review what we learned previously, I know that this polynomial is quadratic because it's degree 2, the highest power is a 2, and it's a trinomial because there's 3 terms. So what I'm going to do is I'm first going to take that negative 3x squared and multiply it by my 7x squared. So that's what you'll see I write down first. Then I take my negative 3x squared, I multiply it by negative x. Then I take my negative 3x squared and I multiply it by 4. You can eventually skip this step here where you're actually writing it out each multiplied together, and you can multiply them in your head. But remember, when you're multiplying this, when you're multiplying monomials, you're going to multiply the coefficients. So negative 3 times 7, that's how you get negative 21. And then you're going to add the exponents. So when you take x squared times x squared, you get x to the 4th. Because you're thinking, how many times is x multiplied by itself altogether? 4 times. Similarly, here we have negative 3 times negative 1. That's how I get a positive 3. Then I have x squared times x to the 1st. That's how I get x cubed. I add those exponents. Then I have negative 3 times positive 4. That's where I get negative 12. And then this is just x squared multiplied by, this term does not have an x in it, so it just stays as x squared. Double check, you need to make sure that all like terms are combined. So remember, like terms have the same variable with the same power. None of these 3 terms have the same power. So we're good there. All the like terms are combined. Next is it in standard form, meaning it's the highest power down to the lowest power. Yes, we're good here. And to review, our final answer here, since it's the power of 4 with 3 terms, it would be called a quartic trinomial. So that's the power of 4, 3 terms. Alright, now let's try another one. Let's say we wanted to multiply this monomial 2p by this polynomial negative 4p squared plus 5p. And then we also have another monomial negative 5 multiplied by another polynomial 2p squared plus 20. So remember your order of operations here. First, check if there's anything inside the parentheses that you could simplify. Neither of these have like terms, so you're going to move on to multiply and divide. So then you're going to take the 2p and multiply by everything in this first parentheses. So we have 2 multiplications here. First is 2p times negative 4p squared. 2 times negative 4, we get negative 8. And then p times p squared, we get p cubed. Next is 2p times 5p. So 2 times 5, that's how I get 10. P times p, that makes p squared. That is the end of that parentheses. So now I'm going to move on to the next set of parentheses. On the outside of this parentheses, I see the monomial -5. So first I'm going to take my -5 and multiply by 2p squared. -5 times 2p squared makes -10p squared. Because -5 times 2 is -10, the first part doesn't have a p, the second part's p squared, so that just comes down as p squared. Next I have -5 times 20. That is just two integers multiplied together. You should know that makes -100. Again, you can skip this step eventually, but for now it might be helpful for you to write it out for your notes. Something that you need to be careful of here is that the negative goes with the 5 when you distribute it. A lot of people forget that that negative has to go with the 5, so they end up with a plus 100 here at the end, when instead it's supposed to be minus 100 because it's -5 multiplied by this entire parentheses. Once you have it distributed, you have 4 terms. You have to check if all like terms are combined. Remember, like terms have the same variable with the same power. So 10p squared and -10p squared are like terms. When you combine together 10p squared and -10p squared, that makes 0p squared because 10 minus 10 is 0. You don't need to write 0p squared because 0 multiplied by anything is going to be 0. So that's going to go away, and all you're left with is the -8p cubed minus 100. This is in standard form because it's the highest power down to the lowest power. It's a polynomial that's a cubic binomial. It's the power of 3 with 2 terms as your final answer. Now I want you to go ahead and try the practice problems below. Okay, take a look at these 2 practice problems, see if you got your answers correct. Hopefully for the first one you took that, whoops, I don't know what just happened there. You took that 3 and distributed it to all 3 terms in this first parentheses, and then you took that -x and distributed it to the, oh my goodness, to the 3 terms in the second parentheses. And then once you do your multiplication, you have to look for any common like terms. So once you combine, you should end up with your final answer. It's a cubic because it's a power of 3, and there are 4 terms here. Double check and make sure you got that one. Now go ahead and check your answer for B. This one did have 2 variables in it, so it was a little trickier. But remember, when you're multiplying them, like for example, if you're multiplying 15t by 10y cubed t to the 5th, you're going to just look at what's alike. So you're going to multiply the 15 by the 10, that's where you get the 150. The t times the t to the 5th, that's where you get t to the 6th. And then you have the y cubed, just comes down because the first monomial, 15t, doesn't have a y in it, so it's just going to stay as y cubed. You'll do the same thing throughout the rest of them. Check if you have any like terms. In this one you do. You have 75y squared t squared minus 2y squared t squared, so that makes 73y squared t squared. For this one, there's not really a standard form because it's more than one variable, so whatever order you put that in is totally fine. If you didn't already try this challenge problem, I want you to go ahead and try that now. It's an equation that you're solving and has an equal sign here, so keep in mind when it says solve, that means you're trying to get the variable a by itself. On one side, the other side should have a number, and see if you can get that. Alright, here's the final answer for this challenge question. It was a equals 2. If you distribute everything, combine all your like terms, you'll end up having the a squareds cancel out. So the quadratic term is gone. Now you end up with a linear equation, meaning that it's just a to the first power. So we're going to get all our constants on one side, our variables on the other side, and then divide by the coefficient of 21 on both sides to get a equals 2. Hopefully you guys were able to get a little bit on that problem, even if you didn't get it all the way. You're understanding how to multiply monomials by polynomials. That's the main goal of what we're learning here today. Alright, you guys will have some practice with this, so make sure you get that done and let me know if you have any questions. Bye.